Okay, let's see the examples. This CT is the quantity of cotton supplied in year T. Okay, and PC is the price of cotton in year T minus 1. So it's previous year's price of the cotton. Okay, and PF is the price of farm labor, means they have to hire some workers to do the those farm work. Okay, so the relationship between the price and the supply of the column is positive, right? The price is higher. The farmer likes to supply more of the cotton, so it's positive. Then if the labor cost increase, then this one will decrease. Okay, because this is the cost increase. Then the supply will decrease. Okay, so we expect the positive relationship and negative relationship, but this one is the previous years. So how do you explain? How do you interpret the meaning of the beta 1? And this is also all in level forms, right? So it's linear form of the function. Okay, so this means that the price of cotton increase by maybe $1 measurement units, $1 or whatever measurement units. Then the cotton supply will increase by beta 1 units, measurement units. So it means that the price of the previous years will have the extra beta 1 measurement unit increase by current year's cottons. Okay, so the explanation is the same, but you have to say that this is for previous year's price. It's not current year's price. That's the difference. Okay, so this is what we say lagged independent variable. Usually we do the current years, either x variables and y variables all refer to the same year, same time points. Since we say the cross-sectional data is always referred to the same time points. But if we have this one, this is not really cross-sectional data. This is time series data. So if we say the time series data, not only the lags in X, but also, not only one lag, maybe more than one lags. Okay, do you have any idea, some kind of example shows the lag relationship in X variables and Y variables? If you study in the research and development, okay, in the companies, usually they have to really contribute several years to do the research in order to have a new invention, right? So in that case, this is not only 1 year's difference, maybe is several years difference. And according to the literature, usually the research, the expenses from research and development, okay, will affect the current years, and the time lag is 4 years. It's 4 years. So in that case, this one will turn out to be T minus 1. Instead of T minus 1, maybe T minus 4. Okay? All right. And, something like this, lag independent variables, most of the situation is about time series data, which is the topic in the next year in another class. Okay? We'll talk about more about these lagged independent variables. Okay, so this is, this is just really just an example. It's a pre-taste of the time series data. Okay, and so this is all what you know. So I mean that independent variables, not only the same period, but also the lagged periods. Okay, and now I want to talk about the big issue of this chapter 7, which is 7.4, slope dummy variables. Do you all remember we learned dummy variables? When we learned that, which chapters we learned dummy variables? Chapter 3. What is dummy variable? Oh, remember that? Categorical variable, and the value is only 0 and 1. Okay, anything else you remember from dummy variables? If I have m categories, how many dummy variables do I have? If I have m category, like, for example, I think we use the example that as a teachers, they have undergraduate, so bachelor's, master's, and PhD degrees, right? So there are 3 categories. So how many dummy variables do we need for the equations? 2. So that's why I'm saying that if we have m category, then we have m minus 1 dummy variables. Remember that. Okay? Then, when we learn in chapter 3, maybe I have this PPT here. Okay. This is what we learned when we in chapter 3. This is called dummy variable, right? There's a y, there's 1/3 of x, and the d. So d equal to 1 is ith observation meets the particular condition and 0 otherwise. Okay? And how do we call these variables, these dummy variables also? You all remember this one? Maybe I need to have my own PowerPoints. Here. Well, I don't have it. Okay. We call this D is intercept dummy variable. Why do we call that intercept dummy variable? Well, remember that? Why do we call this one is intercept dummy? Because we say that when D equal to 1, since D is equal to 1 or 0, right? When D equal to 1, then what? Since this is 1, right? So this becomes beta 2. So which is y is between beta 1 plus beta 2 plus beta 1 x. So the model becomes to this one. Okay? Then if D is equal to 0, then y is beta 0 plus beta 1 x. So really these equations, since we have one dummy, means we have 2 categories. And what are they? Is the first one, when D equal to 1, the category when equal to 1, and the other category equal to 0. 1 means the condition met, right? Okay, so when it is equal to 1, then the beta 2 just affect intercept. Therefore, we say this D, this dummy variable, is intercept dummy variable. Okay? Understand what I'm saying here? Because it affects, just intercept. Okay? So this is called intercept dummy variables. Okay, now I'd like to introduce more about this. This is just small stories. I like to explore more about these regressions. Okay, and this is also related to the functional form. Okay, this means that this X and D. But if I can add one more interaction terms, what do we mean by interaction term? Means the relationship of X and Y. So I'm using X times D as an variables, as a functional forms, one of the variables in the functional form. So this means I change the functional form from the original X and D becomes, I add one more term, which is the multiplication of X and D. And why do I do that? What for? Okay, so if I have this one, then I'll leave this one here, okay? Then I'll using my PowerPoint. Okay, look at this one. This is exactly what I have there, but I add one more term, which using X times D. So I'm using X variables times D as another variable, call it B3. The coefficient is B3. I add this term, we call this interaction terms. Okay, what do we mean by interaction term? Is the multiplication of two independent variables, or even sometimes it's more, 2 or 3. Okay? Okay, then when D equal to 0, what happened is Y, since it is 0, right? And this is 0, right? Then the equation is beta 0 plus beta 1x only. Okay, you see this one? But if D is equal to 1, then this is 1, this is 1. Okay? Then my equation turned out to be the beta 0 plus beta 2, since this is 1, right? Then slope from beta 1 plus beta 3, since this is 1, so I have the beta 3 here. What's the difference between these two? And what's the difference between these two? Go back to this one. Here, the beta 2 only affect intercept. So we call it intercept dummy variable. This 2 has same slope, beta 1, right? But how come here? This D, with the D here, and also the interaction of the X and D, so beta 2 will affect the intercept as usual, but the interaction terms, beta 3 will affect the slope. So the D here is not only the intercept dummy variable, but also the slope dummy variable, because they affect the slope. Look at this one. So it is really explore or really reflect the situations in reality. If I have just this one, this is just some part of the story. If I add one more term, which is the interaction of the included x variables. Why do I have to do this one? Must be have reason from theory. Okay? So I do these interaction terms, then it really turn out a different story. Means that D is not only intercept dummy, but also slope dummy, because it affects the slope. Okay? Any examples for that? If Y is the salary, okay, then X is the working experience. Okay? And D is the gender. Usually we're talking about the issue of discrimination. Okay? It means that if there are any discrimination between men and women about their salaries.
That is economically untrue.
That
is economically untrue. The difference is always, it's not like there is talking about 15 to 20% of pay gap difference between gender, but actually only less than 1% of this pay gap can be attributed to discrimination.
Discrimination is always the popular issue in economics in any country.
It's been debunked already by most economists. So
yeah.
We can take that as an example, but
yeah, just an example, okay? And I don't know whether it is true or not. It really, I don't know. It's a popular issue. Okay, in the world.
Because people like to hear about it, but they don't read about it.
Okay. So if I have just this one, okay, if I have this, if my regression equation is like this, what's the story we end up with? If D is equal to 1, if this is male, this is female. Okay? This means no matter how many years you're working, the slope always beta 1. Means the 1 year's working experience increased by 1 year, it really doesn't affect differently for men and women. Right? Right? As long as we increase by 1 year's working experience, then the salary increased by beta 1 measurement units. So there's no difference between men and women. Okay? But if the beta 2 here is significant, what do we mean by beta 2 is significant? Since we already learned hypothesis testing. What do we mean by beta 2 is significant? After we do this one, we have the beta 2 coefficient. Then we can check the p-values, t-values, right? And if it is significant, it means it passed our alpha level. Then means this beta 2 is significant. Means the difference of these two is significant. Okay? And, since this is just intercept, what is the intercept? We don't have to say much about the intercept usually. But here, in this examples, if this is the whole stories, okay, then we can say that as long as the x equal to 0, then that is the average value of the y, right? So what do we mean by x is 0? Means the starting salary. No working experience, right? Starting salaries. So this, if beta 2 is significant, then we will say that although in the future there's no difference between the increment of the salary of men and women, but the starting salary makes difference. This is what we can say from the analysis, right? Then how about this? How about this? How about this? There are many situations, right? And this difference can be beta is positive or negative, right? If beta 2 is positive, means what? The starting salary of man is higher than the woman. But if it is negative, significant negative, means the starting salary from the man is lower than the woman. But in the future, there's no difference of their increment. Okay? Then how about this one? Again, we can have positive and negative too. So there's 4 situations. So by the way, if beta 2 and beta 3 are not significant, what do we mean by that? Beta 2 and beta 3 is not significant. If we have the data, after we do the analysis, these 2 are not insignificant. What do we mean by that? No matter starting salary or the increment in the future, men and women are no discrimination, right? Then, if beta 2 are negative, since this is a man, this is a woman, right? So if this beta 2 is negative and significant, that means starting salary is lower. And the beta 3, if it is so we have 4 possibilities: negative, 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 positive, positive, negative, and positive, positive. So we can explain all the stories. Therefore, this is 5, including both of them are not significant. So we have 5 possibilities, and here there's only 1 possibility, 2 possibilities. If this is not significant, then they are the same. If it is significant, then positive and negative. But here we do have 5 possibilities, and this is the reality, right? It can be all in the same, or starting salary is different, or increment in the future is different. And it really based on positive and negative. So in this situation, after we add 1 interaction terms of the x variables and the dummy variables, okay, then it creates the more reality, the more real situations. So expand. This regression analysis can explain more in the world. So this one maybe is more popular than this one. It's worthy to add 1 more interaction terms. So this is the functional form change, right? This is what we call functional form change. Okay? This is not missing variables. This is functional form change because we add 1 more terms, which is the interaction of the existing x variables. Okay? All right? And I like to use one of the example to show this result. Okay? Let's look at the data of this one. I already give it to you. Okay, what is this? This is the put it bigger. This is from 1959 up to 2007. Okay, so we have 49 years. Okay, so again, this is a time series data instead of cross-sectional data. Okay, and as long as we understand that the year between 1980 and 1981, starting from the 1981, there's a big recession in economic theory, in economic history. This is 1980, okay? Okay, so we do have one examples shows one dummy variables, which is the recession. So one is the recession period, okay? Then 0 is without recession. Okay, so GPI and GPS. This is GPI is the investment, general public investment, gross public investment, and GPS is gross public savings. Okay, and recession here is using 81 after 1981 as a recession period. Okay, so would you please using the eView to run the regression? 3 equations. One is using just GPI, GPS without recession. Okay, the second one is GPI, GPS. GPI is Y variables. Okay, then GPS and the recession as a dummy, intercept dummy variables. And this is the slope dummy variables. Please run the 3 equations. Would you please do it? And do you know how, I have already have the interaction terms. Okay, so this is Y, this is X, this is D, this is X times D. So run 3 regressions. One is Y and X. Second one, Y, X, and D. Third one is Y, X, and X times D. This is already done, X times D. You understand what I'm saying here? Since you already downloaded, then put this one in eViews, then run a regression. I wanted to have 3 equations, okay? Do you have the same result as I did? Huh?你没有1六，
因为我是平和，
所以你平常怎么
平常
做作业？
他帮我扔，
用他人一起。咦，好像可以，你可以问一下那个，因为我不晓得你写。他说不可以，那我就是用 lab 的。OK. Maybe I think that's also the option. Do you have the same result as I did? So what does this mean? If you save more, there's a positive relationship between them and significant, right? Look at the probability. It's very significant. Okay? Then you add one more, intercept dummy. Then what does that mean? Is this significant? Negatively significant. Either you use the t statistics or the p-values. Okay, t statistic. Did I tell you that the general, you can compare this t statistics with the number of 2 to have the general idea, but it really depends on the sample size. But you can compare with the 2. And since this number is big, really big, positive or negative 2, so it's really big, therefore it's significant. So this means what? The intercept decrease, right? But the slope is the same, no matter before recession or after recession. Okay? And how about this? The beta 1 of the GPS is significant. The D, beta 2, is also significant. This GPS times recession, 81. This is interaction terms. And this is what we call slope dummy. So 0.37 will affect which coefficient? So explain this one for me. So if we explain this one and the relationship between this one and this one we just combine all the datas, 49. So there we say the relationship, general relationship between these 49 years, and the positive relationship between savings and investment, and the coefficient is 1.10, means $1 savings is will create $1.1 GPA. I'm not sure about the measurement units. It's not really dollars. Maybe it's $1,000 or billion or $1,000,000. Okay, so it is really something like 1.1 situation. Okay, relationship. Then, how does this one? The GPS 0.95. What does that mean? How do you explain the 0.95? Can I also show my PowerPoint here? Look at this one. I have beta 0. Now this beta 1 is 0.95, right? And this is what? This is negative 350 something, right? And this is what? Positive 0.35 something. Okay? So they are all significant, right? And let's look at, since we're more interested in slope dummy, okay? So the beta 3 here is positive. What does that mean? This D equal to 1. Okay? So when after the recession, during the recession period, D equal to 0 is before the recession periods. Okay? During the recession periods, the savings and the investment has positive relationship, which is 0.95 plus 3.35 something. Am I right? So it's like 1.3 something. Okay? And which is significant. Means that the slope is really changed. Okay? So those kind of studies, I think maybe is also useful for your thesis in the future. If you want to study the structural change during the relationship, for the relationship between X and Y. And, I don't know what you wanted to study, but after we have this big data age, or without big data age, maybe you can do the, in the marketing or something like this one. Okay, this is really a structural change, right? So it's worthy to study using by slope dummy variables. Okay, this is very useful tools for the study.
In our equation, we have first dummy variable, like the normal one, which is recession, and then we have the slope dummy variable, which is also recession, but the impact on the structure of the slope, right?
Now we have 3 slopes, right?
Uh-huh.
The first one is, beta 1 is what? Before recession.
Yeah, okay.
Okay, look at the equation, I have it.
Quite honestly, I didn't get what were the variable like. Can you recap like very?
The first one is my X,
Yeah.
and the second one will my D.
The actual meaning of that.
Oh, this is the GPS, and this is the GPI.
Yeah.
So the relationship between the GPS and the GPI, the coefficient is 0.95. Before recession. Before recession. When you explain 0.95, if you explain 0.95, this is the relationship between before recession, right? If it after recession, you need to add 0.95 plus 0.37. This is what we said here. This is 0.95. This is 0.37. So this is after the recession. The relationship between the GPS to GPI, the slope is increased. Okay? If we didn't put this structural change as a consideration. Means we don't have D. This is what we general have the GPS to GPI, which is this one, right? This is the first one. This is the general, although, we can see that if we draw the diagram of the GPS and GPI, let me draw the diagram. See what I can do from the diagram. How to do that? Plot? View?
Do you think we should try this check like for
Try.
the variable every time we think we want to use the variable? It doesn't depend on like the actual variable. I mean the reality of the variable. Because here it's a recession, which makes sense for us to try that, right?
Mm-hmm.
If it was something else, still the variable, but some other topic, some other variable. Would you advise us to still try it just to check? Because I mean, it doesn't
Well,
matter what-
there's some relationship you have to base on the theory. Still, you have to base on the theory. And we know this one is from economic theory that recession will affect
continuously.
the situations.
And that type of data, that type of variable so the slope dummy variable, how do you create it? Maybe it's
Using the xn times the dummies. This is what we call slope dummy variables. This is what I'm saying that. This is what I'm saying that since beta 3 will affect the slope, therefore we call this dummy is slope dummy. And this dummy, D only, is intercept dummy because this beta 2 affect the intercept only. So this is called intercept dummy, and this D, which multiply with some important or reasonable x, then it's turned out to be the slope dummy. And in this situation, it will help us to see the structural change between the x and y. Without this one, we don't know the slope change, right? With this one, we have slope change, then you know the structural change in the economy or some kind of market. So this is useful in your thesis. This tool is useful in your thesis in the future.
when you do I think I already asked you, but when you answered, I wasn't ready to understand yet. So when you have your dummy variable here, which will be the recession happening or not happening, right? Then you have the slot dummy variable, which is the continuous impact of the recession on economy, kind of, on GPS, all right? When we compute, for instance, let's say our final regression analysis model, the one we're going to use for our thesis, for instance, should we keep both the dummy variable and the slope dummy variable? Especially since we can see that.
Oh, okay.
Oh no, yeah.
You may think about this way. According to the theory, okay, if we create a dummy variables, which means the different situation, okay, then according to what we have the data, we will collect the data about this one. Just like this one, we have the before recession and after recession. So after we do the analysis, does that results support what theory expect or we expect? Do I answer your question?
Well, I assume yes, but did I understand the answer? No.
Say it again. What do you call?
Because I'm wondering, should we keep like both the dummy variable and the slot dummy variable in the
Well,
equation?
well, sure,
Because I don't know.
sure. Since we have this D,
Yes.
and this one is the interaction of X and D, and we should keep it together, or even we do the hypothesis testing since, well, I'm using X and which this X involved with this one. And if I test with D, the D involved this one, we need to do the partial F test for this two, for this and this, or this and this together, not just only one. Okay? If we see one of them is not significant, but we do the both of this partial test, it may be turn out to be significant. And in that case, you need to keep this in the regression as a variables, as important variables. Okay? All right, yes.
Okay, James, from his questions, can we do the omitted variables into the dummy variable?
Omitted variable?
With the dummy variable?
Oh, sure, sure. Since this is one of the variable, no matter it's a numerical variables or it's a dummy variable, it works. It works. Sure, it is. You know, we're using this even it is dummy, then look at the result. Look at the result. This is dummy variables. But whatever coefficients, standard error, t statistics, probabilities, this, you know, the hypothesis test is exactly the same. So no matter it's dummy variable or numerical variables. Any questions about this? You know, the reason I show this example is, you know, I think this is a good example for the interaction terms, and also is also a good example for all of you to do the structural change if in your thesis in the future if you need it. Yes. Yeah, okay, sure. Good, very good.
So if we omit the dummy variable, the second one, then we cannot continue to that part. So we cannot include the beta 3, which is.
You mean you don't want it to have the D, but you want it to have X and D. Is it possible? Usually we'll do both and see what happens. You know, why don't you want to do the D? Why don't you want to put D as one of the variables? It is important if it is really cause the structural change. It is an important variable. And also, based on the economic theory, if this structural change is already done, it's already happened or occurred in the past, no matter this D variables is significant or not, you need to put it in the regression as an variables, no matter it is significant or not significant. Okay, so we're not just look at whether this variable is significant or not, or let it stay in the regression. You know, we have to base on the theory first. If it is an important factors, like the recession, okay, and some of the example you may study is like 2007, 2008, 2009. I think these 3 years is also the crisis. What kind of crisis is economic crisis? Is business world, like those golden in the Wall Street Journal, Wall Street market is really crashed. And this is important period too. So you have to study related to this one. You can use that period as is something like maybe relationship changed. Okay. All right. Okay, let's take a break. Okay.